This week, Ferruh Mavituna from Netsparker will join us for a feature interview. Got some great topics lined up for Ferruh, so you're going to want to check that out for sure. Our topic this week that comes after our interview, we'll be catching up with our very own Jeff Mann, who attended RSA, will likely need a drink or five to tell us all about the happenings at RSA. In the security news this week, DDoS for hire, evil maid attacks, Amazon Echo devices could be spying on you, GitHub threats, and breaking into hotel rooms. All that and more on this episode of Paul's Security Weekly. This is Security Weekly. For security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. Welcome. Did Larry have an introduction? Hi, everyone. This is Paul Asador, and I guess I'm introducing...
Apparently, I no longer do. Wow, and I look short.
So, yeah, I accidentally landed in New England and stumbled my way to the G-Unit studio.
That's pretty much how I envisioned it happening, Jeff. Carlos, save the show, please.
Yes, somebody's got to do it.
Cannot be saved.
Well, it's good to have you back, Carlos. Jeff, welcome. Nice to have you in studio.
It's great to be here, Paul. Try to stay awake for the whole episode.
Yes. We've been in studio dropping his phone incessantly. Welcome, chat.
What? Where? Oh, hey! I'm in the studio with you guys. That's kind of cool.
Netsparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. Netsparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. In 2017, an increasing number of companies reported they did not have effective insider threat detection methods. LogRhythm's UEBA solutions enable you to detect and neutralize user-based threats in real time, while built-in scenario and behavior-based analytics empower you to expose insider threats, compromised accounts, and privilege misuse. Visit LogRhythm.com to learn how their UEBA solutions can help you expand visibility and enhance detection capabilities.
And welcome to the show. But first, let me introduce you to our host, a man for whom I do not have a witty introduction this week. So, we'll just spank his ass and call him Charlie. Charlie Asadorian!
Why, thank you, Larry. Welcome to Paul's Security Weekly. This is episode 557. It is April 26th, 2018. Of course, we're here in G-Unit Studios, and I am joined by the illustrious even, Larry Pesci.
We haven't even been drinking that much.
No. Yeah, it's after the past couple of weeks. I think we drank enough for the next 20 episodes.
Yeah, I think so. But yet we continue to...
Well, we're taking it easy. We started with beer. Yeah, beer. Maybe we'll get some more beer.
Yeah, I think that's on order for someone to get
Sam,
beer.
Or Tori, someone get some beer. Sam already ran errands for me today. Now I feel bad. She was going to Best Buy, and then... Wow. Oh, no, we ran out of coffee. And then I was like, well, the Starbucks is next to the Best Buy. And then I'm like, well, you know, while you're at Starbucks, I'll take an Americano. Oh, boy. On the lines via Skype, Mr. Jeff Mann is here with us. Jeff, welcome.
Always good to be around and on the air with you guys. Wishing I was in the studio, and I probably wouldn't drink a beer. I'd go right to the hard stuff.
That's right. Because Jeff can hold his liquor, unlike Larry and I, apparently.
I can hold it.
Yeah.
Problem is I don't hold it for long because I do this.
Yeah. So, a couple of quick announcements. Make sure you visit securityweekly.com/on-demand. Check out our on-demand webcasts. They're awesome. You should go register for them and learn some stuff. I now would like to bring on our special guest for this evening, no stranger to the Security Weekly shows, Mr. Ferruh Mavituna, the founder and product manager at Netsparker. Welcome, Ferruh.
Hey, Paul. Thank you. Nice to be here again.
Yes, Ferruh's coming off, and you said you just got back from San Francisco not too long ago.
That's correct. Yes, still recovering.
Yes. Well, Ferruh, it's nice to have you this evening. I want to start off by talking about how we'll dive right into it. Dynamic web application security testing and how that plays into the SDLC. And I think it's interesting for me is like the term SDLC can take, I think there's many different subtypes, right? I think everyone does the development process a little differently. And so certainly I want to hit on some of those different development methodologies, but how does this dynamic testing play into that, and why is it so important in this process?
Hey, real quickly before you jump in, could you just spell out what SDLC stands for our listening audience?
Go ahead, Ferruh, all you.
Oh, yeah. So the SDLC, Software Development Lifecycle, which is kind of, I think majority of the listeners coming from the breaking point of view, attacking stuff, which we enjoy, obviously. So the SDLC, Software Development Lifecycle, and in a modern, pretty much almost any decent web development house, small to big project today, using some sort of development lifecycle process. So what we observe, just to cover the SDLC basis so everyone is on the same page, when developers write a new piece of code, everyone uses a code repository system. So, you push it to Git, most likely. And then you have a continuous integration system, which pulls the data from your Git repository or whatever the repository, source code repository that you are using. And then it triggers a set of actions. So ideally, what you want to do as a software developer, you want to push code, and then what you expect, code automatically tested, deployed, and whatever else needs to be done in between. So some code need to be compiled, need to be signed, need to be packaged in the installer. Some of them is just straightforward deployed to staging environment, or maybe even production environment, which is quite unlikely. So what we cover as software development lifecycle, SDLC, is the point where you start pushing your code to the point generally you deploy into your staging environment, and even to production, like maybe a separate set of tasks. So this is quite common. I don't think any company that calls I'm developing a web application calls themselves as a developers and not using this. I don't see it for a very long time now, which is nice. So we are all in this kind of the best practice. So one of the trends in the last couple of years, we are trying to get security into the development stage. It's, actually, we always wanted to do that, but it kind of wasn't happening that well. But now with the new terms like DevOps, SecDevOps, this became kind of a huge part of the discussion. And if we kind of step back a little bit, how we get here, think about all agile development movement, and where we are today, where the company is deploying multiple times a day. This is all possible because we got much better software development lifecycle, much better, much mature tools, and this is kind of the best practice today. So from security side of things, we always used to say, security is not a product, security is not a thing that you can add on later on, it's a process. Having said that, in practice, it never was a process. And even if it was a process, it was a different kind of process, which introduced much later on. And, if you worked as a pen tester and seen the security from that kind of point of view, what you must have seen multiple times, projects are only being pen tested almost pretty much right before the deployment. So that's where we are about the SDLC. And the ideal world, what we want to do, introduce security into the development itself. And there's a really big reason for it. The biggest reason, arguably, is the really short feedback loop. To give you an idea, let's say, Paul, you hired an intern and started to work with you in Paul Security Weekly. And then the very next day you hired him, he makes a mistake, okay? You don't say anything, then you move on. 2 months down the line, you show up and you start shouting about that mistake, right? And obviously this intern is like, what the hell is going on? Like, I don't even know what you're talking about now. Because what happened is, he made a mistake and you informed him about that mistake 2 months down the line, and obviously it's very ineffective. So what we have been doing in vulnerability management or, security of web applications or other software as well, that's what we have been doing. Developers are developing codes that we are testing them 6 months down the line, 1 year down the line, or even worse. Sometimes you go back and the original developer is not even there. So the idea is, if developers write a piece of vulnerable code today, can we inform them the very same day, if that makes sense?
Yeah, or even, minutes or hours. Ideally, that's what, is being recommended, is to have that continuous feedback loop. And of course, that is all borrowing from manufacturing, right? When they had a manufacturing assembly line, if there was a problem somewhere in the line, that the information about that problem has to flow back to someone who can fix that problem immediately. I think it's the same thing. Jeff, you and I worked in vulnerability management. It was a lot of conversations we had where, we're doing regular vulnerability scans, but I'm like, where are you sending that information? Oh, we do a report and might send it to this person. I'm like, how quickly can you discover a vulnerability and report it to someone who can actually fix it? And that in manufacturing or in software development or in your IT operations, that's very, very important.
Oh, definitely. So that's why, embedding security into SDLC is important. And historically, static source code scanners are very well embedded in SDLC process. But what we have seen in practice, and I've been talking with prospect customers quite often, what is your SDLC looks like? What kind of security tools that you embed into your SDLC process? And how it works for, let's say, static source code scanners, developer write a piece of code, so it goes into the continuous integration server, it builds it, or even without building it, it runs through the static source code scanner. Then if there's a vulnerability, it reports back, and depending on the settings, it breaks the build as well. This build is unsuccessful, so you got to fix it. The biggest problem in that, what we have noticed when we talk with the customers, this is good because this is fast. One of the problems that you don't want to run an 8-hour scan. The scan must be within, as you said, minutes, ideally. If the worst, maybe an hour, but you cannot make it wait any longer than that. It's just not feasible because they want the results, rightly so. So in static, though, they run into this problem of developers are getting reports and their builds are breaking. But the problem with the static, you run into the false positive problem, right? And in the dynamic, you still got the false positive problem, but on top of that, also scans are slower. So dynamic is, again, historically, the core reason why we don't see dynamic scanning in SDLC is pretty much that. The performance of dynamic scanning is challenging. And the other problem, you have to deploy the application. So you cannot just test the source code. It's not going to work. You have to deploy a working copy of the application. In an ideal world, majority of the continuous integration service and the SDLC process includes a staging environment that you automatically deploy. So it can be tested. But as I said, the dynamic testing the process takes too long. And so in order, you got the false positive problem, so developers cannot rely on the results, and they are doing this commit every day, every time. So it has to be valid feedback, not just rubbish coming out, and they have to review 5 times a day. And secondly, it has to be fast enough to justify, okay, this can be part of the process, rather than completely out of process thing, which we do once a week, kind of.
Ferruh, do you have examples? And I know this is one of the advantages for dynamic testing is that, it's testing the application once it's all put together in runtime, and that's really the only way you're going to reliably find a lot of these vulnerabilities. And because there could be a vulnerability in the source code, but it's in code that would never execute or be exposed, and therefore isn't a risk. And when it's static, you don't know what that risk is. You only understand it when you're in dynamic. Do you have some good examples of vulnerabilities like that?
I think, yeah, definitely. I think one of the biggest example, static versus dynamic in that sense, what I observed in static, let's say you have a function, and a function says, make this cross-site scripting secure. So it says encode it, right? And then some developer written a piece of code to do that job. In static, because you don't execute the source code, right? What you get is you mark this function as working safe. Meaning anything going through that function now will be treated as it's safe for outputting in a cross-site scripting context. So, but the fact that if the filter is not good enough is bypassable, no one knows that. because you don't have that capability
Right.
of actually running an attack and see what filter actually does to that input and see if the filter is actually valid enough. So these are quite a bit pitfall, which we have seen in practice. So the dynamic finds a vulnerability, and the static just assumes the filtering function was working correctly. But almost the bigger problem in static is what you're gonna get, the accuracy of it. You will have problems with combination of systems, where it deployed. So like PHP is a prime example of this. There are so many PHP configurations that you can do wrong. And with the combination of the application you have, like the old school PHP magic codes, which doesn't exist anymore, that's nice. But all the checks like that, combination of the live application also can lead to problems where static will never even able to see because they never exposed to the live environment that it might be deployed. And the other problem is just pretty much what you said, that static just goes through everything, looks everything, even the code is never executed. And on the other hand, even when the code executed, it doesn't know how some interactions are going to play out in real world. And we have seen so many examples of that.
I thought something else in our notes, Ferruh, was interesting that I had it put together, right? Because I've done some programming in the past, and I've been a programmer for a little while. And when I write code, and I go back to it months later, or maybe I leave on a Friday and I come back on a Monday, and I'm like, what did I write? I have no idea, and it takes me hours.
And it's not even in Perl.
Yeah, exactly, and it takes me hours to figure that out. But now we talk about this continuous delivery system where developers are in near real time being alerted of issues that they can go fix, and that code's fresh in their mind. I mean, and that's a thing, not just for me, but and not just for people who like to code, but when you're a production software shop, that's a thing. Getting those problems fixed while that code's still in developers' mind, is that something you're seeing in enterprises today that are developing software?
The idea is definitely getting there. In practice, not really. I don't think I've met with anyone who says, oh, we got a fantastic security process and the tool integration on our SDLC and it just works. Or it even finds, let's say, 20% of the vulnerabilities. So what we have seen, it doesn't really work that well at this point. But the dream is exactly what you are saying. Right. And that's from Netsparker point of view, that's what we've been working on. Like, how do we fix this feedback loop in an effective manner? Like, you got to get rid of the performance problem. You got to get rid of the false positive problem. And also you got to close the loop. Like, if Paul is committing the code, you cannot create a ticket for someone else. You want to create a ticket for that individual. So they immediately get the feedback and no one else. So, he knows he broke the build. Now it's his responsibility to look at the code, fix the mistake, and never do it again, ideally. And then, make a new commit so the build is working again. But if you don't have that loop, what you're going to end up with, what happens in practice, and that's why this system doesn't work well in real world. People create, all the tools, create ticket, like break the build completely, or create a ticket to someone like one manager, and then that manager gets in touch with that developer, and with all these distributed teams, you still got that problem of, okay, one problem, and it's going to take days to get to the bottom of it and actually fix it.
Well, one of the other aspects that I think is interesting that I hadn't really considered before is, in wondering when we get into the details if there's differences, right? But in any process where you're notifying the developer that there's a security flaw, is it an opportunity for them to learn how to write more secure code? And my follow-on question to that, what's better for training the developer? Is it static analysis, dynamic, or are they pretty much on equal footing in this case?
Well, the training part is huge. So if you, I remember so clearly when we do a pen test, when I find a particular kind of vulnerability, and especially if I'm the first pen tester on that project, I will find that vulnerability all over the place. It will be just all over the place because it's clearly same developers just doing the same mistake, regardless of wherever it is. And because some of the security problems, it's not clear that they have to centralize those functions because, as a developer, you wouldn't unless you understand the security context of those functions. Therefore, what you end up with is the very same vulnerable code pattern. This is like a couple of lines only, used in every single page. Therefore, if you trigger a vulnerability earlier in the development, and if you can notify the developer about it, they will see that mistake, they will understand the problem, they will fix it, and they won't repeat it again. And if they do, then a new ticket will be created. So like it's in their favor to not do it. Obviously, they're not going to repeat the same mistake 30 times. They're still doing it. Then there's something else is wrong.
Right. Yeah.
When what you said is interesting, static versus dynamic. So the advantage of static, you actually show the piece of source code to the developer. Mm-hmm. So it's very closer to what they do. They can see, okay, I write this piece of code, and apparently input is coming from here, going to there. So they immediately got a better understanding of the vulnerability because they are in the source code level. But the problem with this static, the chances are that being false positive is too high. So if you start reporting false positives, then developers will lose interest and you will run into that crying wolf issue. I keep getting these vulnerabilities, and even when there's any vulnerability, then you got the risk of, they're going to skip it, assuming it's a false positive. On the dynamic, for Netsparker, for example, we deliver the vulnerability with a proof. So what happens is when developer gets, let's say, SQL injection, they get actually name of their database or some sample exploit from their database. So to prove the vulnerability is real. So, and only trigger tickets if the vulnerability is proven, which solves that problem. But then developers still need to make that mental connection between, okay, I've written this piece of code, introduced any SQL injection, and it's on this page, it's on this parameter, but it's still up to the developer to find the exact line of code, where was that piece of code that I've written. And generally, because these are commits, it shouldn't be more than, couple of maybe 20, 50 lines of code. Generally, you don't push around 1,000 lines of code in one go.
So with dynamic testing and I think there's been a perception, and potentially in this case from developers, of a high rate of false positives. Now, having used a lot of these tools firsthand for many years, I think it's gotten better. And I think that, the dynamic tools kind of get a bad rap based on historical things. And even in the past few years, I think we've seen huge strides in the accuracy of dynamic tools, making them something that you want to put in your process and have developers work with. And Ferruh, of course, the Netsparker tool does a fantastic job of validating and exploiting that vulnerability. What do you think we need to do to change that perception that people might have of dynamic tools and with relation to false positives?
I think it's pretty much just, as you said, it's part of the process. I mean, one thing we are trying to do, and I think that's part of the key discussion, need native integration with continuous integration tools. And the other part of the discussion is, can you make the connection between who commit the codes and introduce the vulnerability? So closing that gap is quite important, so you don't end up, issuing fixed tickets for fixed person rather than when you are in a big team and so many different developers is working, then the feedback loop gonna get shorter if you assign it to the right person. But finally, what you said, definitely dynamic scanners are much better than what they were. And a lot of people that I talk about, and they straight away say, oh, dynamic scanning just doesn't work, does it? It won't able to crawl, or it will report so many false positives. Which was the case, honestly, when we got around 10 years ago. I remember when we first launched the Netsparker, and there was a couple of benchmarks around, and the state of dynamic scanning was so sad. Even we were a newcomer, and our coverage was better than majority of the players. Mm-hmm. So you're looking at an industry that everyone kind of ignores because it's very hard to quantify. And I always say this, think about dynamic scanning as you bought a dynamic scanner, and if it doesn't find a vulnerability, you are happy because you assumed your website is safe anyways. If it finds a vulnerability, you are happy because it found a vulnerability that you didn't know. So, but it's very hard for you to say, okay, this is 90% accurate. Or there were 10 vulnerabilities I didn't know, and it found 10 of them, but obviously you didn't know. So for a normal consumer, it's extremely hard to figure out whether they are getting value or not. And it's almost a long-term thing. And if your experience has been tainted by a couple of tools, then you will say, okay, this just doesn't work, and you just kind of ignore the whole thing, and whatever the next best thing you can do, you will start doing it.
But it sounds like if we use these tools, we should be happy no matter what. Like whether it finds something or not, it equals happy. So I'm going to go get more of these tools so I can be more happy.
Yeah, I mean, if it finds nothing, we're happy.
If it finds
If it finds something, oh my gosh, we can fix this. I'm happy.
I love that, Ferruh. That was awesome. We talk about the potential performance impacts, and I don't, and we can talk about whether you run these against a production environment or not. I think in the context of this conversation, certainly, it's my plan and everything I've understood to basically deploy it in an entirely new environment, spin up some scans against that environment, collect my results, and then spin that environment back down until the next release cycle. So performance doesn't necessarily mean impacting the application. Performance is how quickly can I spin up a new environment, scan it to completion, and get those results back. Like Ferruh was saying before, if that's a day, I remember way back in the day we'd be running scans like, day 4, my web application scan, still running. It's about 80% done. We're good. So scan time, I think, is what we mean more by performance, right?
Oh yeah. Performance in SDLC matters. Actually, performance in general in DAS kind of shifted. So back in the day, we were focusing on how can I quickly scan one website. But later on, what happened is recently, we are saying, okay, you are scanning 100 websites. So it doesn't matter if one takes 8 hours or not, as long as you finish 100 websites in 8 hours. Which is like kind of good because the game kind of shifted to parallel processing rather than just, a single threading almost. Having said that, SDLC brings that the very same concern back to the table because SDLC, we want that shorter feedback loop. The way we solve that problem in Netsparker, we do incremental scans. So we dynamically determine what parts of the application changed and only scan those. So there are some downsides to it, but the upside is the scans now is very quick. Your first scan in the application will take some time, but after that, every single commit will take something like, let's say, half an hour, which is a good thing.
Yeah.
But what you might miss out if there is, and again, this is like where static actually, is better. Static says if there's a piece of code changed, but it doesn't affect anything from outside of point of view. So no new parameter is implemented, no new page added, nothing has changed in the application when you crawl it. Then dynamic will assume it's the same application, whereas static can see the changes. What we do in practice with the customers, they run incremental scans in every build, and then they schedule a scan like overnight or weekly, depending on what they want to do, which is kind of best of the both worlds. You get the immediate short feedback majority of the time, but if it misses, you still get that vulnerability the tomorrow very latest kind of.
I forgot that feature was in there. That's a great feature with the incremental scanning. I like the strategy. Jeff, you had a question?
Oh, I've got so many questions. I should have jumped in earlier. And I will apologize ahead of time. Web app scanning, like pen testing, is something I did many, many years ago. But in the more recent past, and why I started with asking the question, what is an SDLC anyway, is because I did PCI for 10 years. And one of the PCI requirements, actually a series of requirements within PCI, has to do with talking to application developers at the organization where you're assessing them and finding out things like, do they have an SDLC? Are they following their SDLC? And silly little things that made a whole lot of sense to me coming from an engineering background in the DoD where things were built over the course of months and years, and so all that is background. I almost hear you saying in terms of the SDLC, and I get that, and I get this. I've seen this in terms of, sort of it doesn't work in the real world. Is people, if they have an SDLC, rarely follow it. I mean, I used to struggle with my customers to come up with an SDLC, and I used to try to at least get them to just walk me through what they do, because they follow a process whether it's written down or not. So first question is, do you think SDLCs, and take notes because I'm just going to rattle them all off. First question is, do SDLCs need to be written down? Do they exist if they're not documented? That type of thing. Just in the most recent discussion, I'll skip ahead a little bit. The idea of do you scan in a production environment, or do you spin up a test environment really quickly? What I heard you saying in the early part of the discussion in terms of, people just sort of ignore the SDLC if they do have one. They think it's irrelevant. They just plow on. Kind of, SDLCs that I'm accustomed to require separate test and production environments. So my initial thought was like, why bother if they're not going to follow any other part of the SDLC? Why bother this one?
That's a lot of questions. Let's let Ferruh answer those first.
So I got a couple more, but yeah,
okay.
I'll go ahead and pause.
So let me start from that. So to be honest with you, I'm actually impressed by the implementation of very good SDLC practice in many companies today. So what happened though? SDLC, whomever is implementing the SDLC at top level, which generally like tech lead, the managers, now DevOps, etc., whomever, right? What everyone figured, if we write this down and expect people to follow up, no one will. So we will automate the whole thing, and that's what they do. So today, what you get, like we say SDLC, but in practice, what happens is for an individual developer, they just push the code, and everything else happens automatically. And any decent company I've been in touch recently is using some form of this. And it works relatively well. What doesn't work though, they implement individual automated tools in between, like, check for the code standards. Like, you cannot name the variables like this. This is my standards, right? So some companies implement it in the automation level and start ignoring all the reports. Like, okay, I should have named my variables like this, but no one cares. So we will keep getting the reports, but everyone will ignore. And some companies, on the other hand, even enforce that to a point. If you do that, it will break the build. So you have to fix it. If you want to be a developer on that team and push a code to build something, you have to fix it. So almost just by designing the system in a way, it doesn't work any other way, they made SDLC work, which is nice. And on the production staging discussion, again, majority of the SDLC practice I have seen today is actually follow that very good best practice. They have a staging environment. It doesn't have to be spinned up every single time, which is super rare in my experience, actually. It's always one instance of a fixed staging environment. They push it, the auto builds after the commit, deploy to them automatically. And then for production, there's a complete separate process. But for that staging environment, most of the time, developer push the code, and then within half an hour or so, they got a new instance up and running in staging. And I've seen this quite a while. In our company, we've been doing it almost a decade now. So it's relatively old. When we started, it wasn't that common. But when I look around today, I think it's very common practice.
Ferruh, I came up with a model that in our testing of our local software here, I wanted to run by you in this light, and Jeff kind of speaks to your question as well. So you've got a development environment, you've got a production environment, you've got a QA environment. And we'd run into a situation where, okay, so someone in production has found a bug that we need to, that they don't understand like exactly what happened, but there's like something failed and we have to investigate. And I'm like, well, your development environment isn't going to necessarily match production because you're doing development in it. Right. And your QA environment, I mean, maybe that's a mirror of production, but likely even if it is, it's probably more closely to what development looks like and is undergoing these processes to find bugs in QA. So it's probably really busy. So I almost feel like there needs to be like a semi-regular or maybe a regular mirror of production
to a test environment.
It's a test environment, right? That you can then go into that environment and say, well, can I verify this bug? Now, in DevOps, that can be, because we've unified the operations component, like I can just automatically create a testing environment. In fact, I can maybe have multiple testing environments, you know what I mean? I can have a dev to testing that's separate from QA. So anyway.
Yeah, I mean, we've even seen some companies uses this. It's very cool, but kind of hard to manage and deploy. Every time they make a commit, so every version of your code deployed in a new dynamic kind of subdomain. So like every version of your code got a live sample. So in your example, you can actually kind of go back and immediately spin up your production version, whatever you deployed. In a lighter implementation, generally what happens is you have one development environment, which is kind of development testing environment, internal. Then you got kind of pre-production staging environment just before you deploy. So it's the exact copy of your deployment. And sometimes it even connects to your live database because, you're going to deploy it anyway. It's there. And then you got your production. So kind of three environments solves the problem that you mentioned because you always have the copy of the testing environment and exact copy of the live in terms of code. You generally still don't want to connect your database like that. And then you got your latest and edge version of your development version at that point.
Yeah, I feel like this testing environment, Larry, now that you say that, it kind of goes back to some models I've seen in the past. I feel like that needs to be on the same data as production, at least in some of our applications. I'm sure many applications, right? The bug is not really easily identifiable in the other environments. It's because there's some kind of data in there that has triggered, or some kind of user behavior that relies on the data being in a certain state that is the only way to reproduce that problem. Which begs the security question. You have to protect your testing just as much as you protect your production environment in terms of protecting your data.
That actually touches on another question I had, which is, back when we used to do web application testing, it was very important to sort of test from the various perspectives. Very often web applications back in the day, I don't know if it's still true these days, had different user levels. There was the basic consumer level, but then there if it was an application that was sold to companies, there might be a company admin level, and then there might be higher levels, sort of God admin type of levels. And it was very important to test from the various levels, as well as sort of, you were talking earlier about, the automation, if I was hearing you correctly, to paraphrase, can only go so far, and that's understood. But some of the things that I was wondering about how you address, or how do you recommend people address, what the limitations of your product is how do you do things like test from the perspectives of different users, different different privilege levels in an application? How do you substitute for, you just don't know what happens until people start playing around with the application and abusing it because for whatever reason, mostly because they don't know any better.
Yeah.
Right. So the role issue, actually, you're very correct. It's maybe even more so today. We got so many roles in applications, so you have to be testing, authenticating testing, and you have to be, test from the different role perspective. So you need multiple credentials if possible. So it's very well solved problem though from dynamic point of view, and the authentication is a very well solved problem, and the roles are very well solved problem as well. So what, for example, Netsparker does, you can configure it in a way. Okay, login as this user, test as this user, test as this role, whatever. So you can have all that combination. When it comes to limitation, I think it's super important to understand the strength and weaknesses of your tools, whatever your tools are. I mean, if you are using a fuzzer, if you are using whatever the tool, then you need to understand what they can do and what they cannot, and where you need to kind of step up or step in more likely. So in dynamic, there are a couple of things that dynamic is great about. So the biggest thing about dynamic in web application scanning, I think is very important. Let's talk about the SQL injection. It's like super common. It's getting less and less nowadays, finally, after so many years. But it's still very common. So if you have a pen tester doing a black box assessment, to determine whether a parameter is vulnerable to SQL injection is gonna take you roughly about 30 to 50 HTTP requests, okay? So there is no pen tester in the world who's gonna go through this. Like, they are gonna throw some junk, they are gonna look at the output, and after 5 requests, they are gonna determine whether there's a SQL injection or not. And they will be, or can be, wrong. That's it. And like, I think majority of the people had some pen testing experience in here. It's extremely common to miss vulnerabilities. It's extremely common when you pen test the very same application twice or 3 times or 4 times, you still find the vulnerabilities because last time around you didn't throw that, now you threw 5 different junk, right? So this is the biggest advantage of Dust. Dust will be comprehensive. It's not gonna say, oh, I've tried 10 things, I'm tired now, let's move on. Or I'm bored now, and that's what pen testers do. It's just human. And the second aspect of it, so black box testing requires comprehensive testing. Second, and one of the other biggest problems, Dust actually knows more tricks than your average pen tester. Let's say cross-site scripting or PHP LFI is a very prime example of this. LFI in PHP got so many tricks that that allows a good pen tester to bypass the filters. But your average pen tester will just not know that much details about PHP and LFI at the very same time. And they also need to know the similar trick for, let's say, Ruby on Rails, and the JavaScript framework, and a bunch of other things. But all of these baked into Dust. Because like in our case, we are building a product, 10 years in development, and in man years, I don't know, maybe like 15 man years kind of research baked into it. So we don't just like read 2 LFI papers. Collectively, our team reads every single LFI paper ever written and everything presented in last year Black Hat or the recent Black Hat or the DevCon or whatever. So you got this constant high-level research baked into the product. So this, again, your pen tester's gonna miss. And then the one final thing is a very prime example of this. Out-of-band attacks, kind of very specific and hard to set up, infrastructure required attacks. So in that case, to just figure out if a secondary system is vulnerable, you have to set up a DNS server. It needs to run a custom DNS server or like some sort of custom open source application supports this. And then you need to carry out out-of-band attacks. And also, this system needs to be able to notify you if something is triggered. So imagine you send a payload to web application, and it's locked in a different computer, in a different web application. Every midnight, it's been processed. And let's say there is a cross-site scripting, something like code execution or SQL injection in that. And a Dust will find that. A good Dust will find that because we invested into all that infrastructure. But again, your average pen tester, they're not going to bother to set up all that system because they're like, what are the chances of finding that? And even if they have the system, they're not going to send those payloads. So these are like what is good about Dust. Let's talk about when the tester needs to step in. So these are all the vulnerabilities that requires logic. And the very simple logic bypasses such as you got 3 pages of remember my password feature. And the first page says, what is your email? Second page says, what is your mother maiden name, something like that, very, very bad. And the third page, okay, here's your password, right? So like the oldest trick in the book, you go to the first page, enter your email, and the third page you have is, let's say, the final step.php. Then you go to the second page, you don't enter anything, you just enter the URL of the third page, and it gives you the password. So your dynamic scanner or static scanner or any other scanner is not going to find this. Like, this is a human level issue. You need intelligence. You need to understand the context and the process to exploit that.
Wait, and Ferruh, we can't use we can't use artificial intelligence today to do that?
Oh, we can. Actually, that's the thing. And like machine learning, will play into this in the future, right? And we got early examples, but nothing like actually making an impact. AI, in like machine learning, if it's like some subsection of all AI, I think not true AI, but like good enough AI actually gonna make a big impact. But possibly when we get that good enough AI, I guess we will have lots of other implications of that anyway. So we are not there yet, but that's exactly what requires.
When we have that good enough AI, they'll replace all of our developers, and then we won't have any flaws and need tools to assess the security of them. That's deep.
True. When does AI just write the code in the first place?
That's right. Wow.
And then we use AI to analyze it.
I didn't expect it to go here, but that's some really interesting insights, actually. Some good stuff to chew on.
When does machine learning get involved?
Yeah.
Actually, machine learning is...
it's been involved. I think that's what Ferruh's probably about to say.
I hope so. Very applicable. So part of the problem with the DAOs, you need to figure out certain steps. Let's say there's an application, and as a pen tester, you go in, and it says register, and well, you click. You're going to register. You're going to create a new user. You're going to look at your email. You're going to get that password, right? From a DAO, but you need to figure out this registration page. You need to figure out what input means what. And you need to figure out to check your email and match that password and then go back and log in. And if there's any other extra step with an instruction, you will be clueless. So actually machine learning has the potential to fix that problem and very suitable for that. So with machine learning and a couple of other data classification algorithms, you can actually make sense. Oh, this looks like a registration page. And you know what? Let me try this. And when the page tells you, you got to choose a password with, let's say, at least 15 characters with these special characters, machine learning can actually figure that out as well and go back to the page and enter that new password. And almost brute force up to a level, but also learning in between. And more you do this, it gets better, etc. So it definitely got that potential of addressing limitations of some limitations of dynamic scanning. Certain stuff like the forgot password example is still heavy reliance on context and much better understanding of what's going on. But the stuff like, now I can register, now I can log in, now I know what every single page is exactly almost. I'm looking at the shopping cart. And now, instead of a number, I'm going to enter a negative number. And when I get the response, I will actually understand what the response means. Like my shopping cart is now $0 because negative numbers are working in the shopping cart.
Right.
You have two items, and the first item is one copy of that item for $10, and the second item you are buying minus one copy of that item for $10, and now your shopping cart is $0, right? So dynamic cannot do it today, but with machine learning, we will actually get that. We will be able to do that kind of systematic, but requires minor learning elements.
Jeff?
So you mentioned shopping cart, and I was thinking, sort of a practical application question. Again, going back to PCI, very common with e-commerce applications. The trick for merchants to be able to not have to do as much PCI is to when it comes not fill in the shopping cart, but when it comes to checkout, redirect to a third party. Or to some degree redirect to a third party, or put the third party, payment application segment in a frame or something like that. What do you recommend, or how does your tool work for, websites, e-commerce sites where not all the content is necessarily yours?
Yeah, that's one of the challenging issues. I think the implementation-wise, as a developer, that's generally what you want. You don't want to deal with PCI. You don't want to deal with that security issues. You just want to, outsource it to a third party. Like companies like Stripe that's why they're super popular nowadays. Mm-hmm. Having said that, the security point of view, that's where also it gets challenging. So what is your scope? You can only scan what you have. So if it goes to, let's say, stripe.com, you're not going to scan that website. And by default, it's excluded from the scope of your scan in the tool. But on the other hand, you want to test the interaction with the third-party tool and your tool. And that's where the human element comes in. So one good thing about dynamic, you don't have to always, tool does it, and this is what I had to do. But majority of the time, you can say, you know what, I'm going to teach this to the tool, because it cannot figure out itself, but I can teach it. A prime example of this, let's say there is a form and it requires social security number. So you need to provide a valid social security number or product ID or something like that that tool wouldn't know or figure out, but you would know because you have the database, you know what it expects or from which range, and then you provide. So this is a very simple example of how you can train the tool to work better. And third-party application interaction is quite similar to that. So even though you're not going to be able to test the third-party applications, what you can still do, you can proxy all that traffic and import back into, Netsparker, and then Netsparker and the tool, adjusts, if it got that feature. What it will do, okay, now I know this interaction, even though I didn't discover it, that information is imported into, the tool. Then it will go ahead and test it, but again, not the target. If there's obviously the vulnerabilities in somehow target, well, that's not your problem anyway. That's your payment provider's problem, and they should be using their own tool and testing process.
Well, it's interesting, though, because when, I've done web application assessments in the past, you run into some of these roadblocks. In other words, if some code on my website is actually from, using Stripe as an example, embedded in my web application, I can't test that because it's living on a system that I don't have permission to test. And I'm sure you've run into that before, Ferruh, correct?
Oh, definitely. It's today, actually, it's so funny. You look into any modern web application, it's very easy to find something like 100, 200 external libraries. And almost like 10, 15 of them is just live frame JavaScript level integration. So open up your sniffer on your browser and go to a popular website without ad blocker. And what you're going to see, all these XML/HTTP requests, all these requests that the page is doing to all these third parties, and your cookies are all over the place. Your Facebook going to detect you, all the other social media, Twitter, etc. Whatever you can find, all this JavaScript is running on it. And when you test, you kind of got to ignore all of them. But in reality, every single thing you embedded, if you don't embed it in a sandbox model, and some of them just doesn't work in that kind of sandbox model anyway, then you risk being vulnerable. So you put Facebook on your website, meaning Facebook runs JavaScript on your website, meaning Facebook can execute cross-site scripting. Facebook can execute JavaScript on your website. That's the bottom line.
Yeah, it works in the opposite way as we were describing before. Yeah, it's interesting. Ferruh, other announcements you have from Netsparker, or any announcements from Netsparker, I should say, or things you want to drive our audience to go check out?
Sure, yeah. Nothing big, but since we are talking about SDLC, that's what we've been working. So just want to brief info about that maybe. So all the problems that we talked about, that's what we've been addressing for the last year or so and testing on the customer. So native integration into SDLC, integrating with tools like Jenkins, TeamCity, and integrating with your bug tracking tools. And the flow right now, a developer commits a code, it goes into the continuous integration deployment servers, and then a new incremental scan kicks off, and it takes about 30 minutes. Then if there's a vulnerability, it creates a ticket on your bug ticketing system for that developer. And when the developer fixes the vulnerability, then Netsparker goes ahead and retests the vulnerability. And this all happens kind of automatically. So as the security team, you're not even involved in this process. It's just being fixed almost automatically. Everything works. And because we also solve that false positive problem with proof-based scanning, proving vulnerabilities are real, showing the data to the developers, that solves the problem of false positives. So this is what we've been working on, and recently published a new update to bolten these up. So we got the committer integration. We have better integration with tools like Jenkins and TeamCity, continuous integration tools, and better integration on the bug tracking tool side. So all that workflow is baked into. And so if anyone is listening and looking to figure out, okay, I've got 100 applications in development, 500 applications in legacy process, that's the exact problem we are solving now, and solving in a very good scale, and have deployments with 5,000, 6,000 applications, which is surprising because you don't think people might have 5,000, 6,000 applications for web services, but apparently they do.
Oh, that's awesome. Ferruh, it's always a pleasure having you on the show. Thank you for joining us this evening on Paul Security Weekly. With that, we'll take a short break, come back, and check out what's happening or what happened at RSA with Mr. Jeff Mann. Stay tuned.